Okay, this is either the second, third, or worst slot in the conference, but you can either get the first thing in the morning when people are sort of only marginally caffeinated. You can then get the very last slot in the afternoon where everyone is like, I would like to go somewhere else and get caffeinated or alcohol or anywhere but this conference. So after lunch, you're all digesting. So please don't hesitate to jump up and down and ask questions. It will aid with the digestive process. In between that process, I'll be talking a bit about Docker and talking about containerization. So I've been doing this computery thing, as my parents describe it, for about 20 years now. I was just saying to someone before the talk, I usually print out a thing that explains what my new job is to my parents every time I get a new job. But I've been an operations person about 20 years and on and off a sort of developer and engineer, a very bad one. I've been involved in open source about the same amount of time. I think I first installed Linux off some floppy disks, so that dates me. For those of you who are too young, a floppy disk is like a DVD. Wait, hang on. It's like a USB key. No, it's like the cloud. So you also may detect that I have a funny accent. I'm not from around here. I'm actually from Australia originally. My accent does throw a few Americans every now and again, and actually, arguably, it throws anyone who speaks English. So if I do say something you don't understand, wave your hand in the air. I will try and speak slowly. If you didn't understand something, it was probably a swear word, and you're just safer not to. I'm also writing a book about Docker called The Docker Book. Please go and, if you would like to pre-order it, you can. If you'd like to stick your name on the mailing list, it's going to be like an introductory guide. And this is how I pay my mortgage outside of my day job. Or at least it pays for holidays every now and again. My wife describes us doing more things for free, you bastard. So, who here is a developer? Oh, lots of developers, that's good. Who is an operations person? Who here does both? Is anyone here a truck driver or lost? Yeah, okay. Yeah. He works at DigitalOcean, by the way, wonderful hosting. Those guys definitely know something about operations, hopefully. So the reason I asked this is that this talk is really about, last few years I've been heavily involved in sort of configuration management and sort of that sort of sysadmin things. I was one of the founding employees at Puppet Labs, and I spent the last few years trooping around talking about Puppet. And as I started to give these talks, the really interesting thing about containerization and about virtualization overall is that I found that my audiences have started to drift from being purely sysadmins to being more developers to actually being developer-centric. And I'll talk a bit about why that's really exciting to me and about why that's sort of exciting from the point of view of containerization and why Docker is interesting to developers. So what is Docker? Docker is very loosely a framework that is built on top of container virtualization. So what's container virtualization? We're gonna dig down into the onion here. So most of you are probably familiar with virtualization. You almost certainly have used some sort of virtual machine at some point. Essentially, it's there is a box, and on top of the box there is some sort of virtualization software, and often described as a hypervisor. And on top of that, you run a virtual machine. And a virtual machine is essentially another operating system and another bunch of files and configuration. And you can use that to, say, deploy code or to do testing in. Or if you use something like Amazon or EC2, then essentially that's your production environment. Virtualization has been around in various forms for quite some time, but really it's been commoditized. It's been actually available to people, sort of stuff you can run on your laptop for sort of 5 to 10 years. And sort of the big sort of tools there you're probably familiar with. I see a lot of MacBooks, so probably some people have VirtualBox installed. Some of you maybe are VMware customers. But Red Hat, Oracle, all sell things that are sort of virtualization technology. And if you're a little bit older, you may have been familiar with sort of, Solaris and IBM also sold some stuff. And I'll talk a bit about that in a minute. Container virtualization is kind of I won't call it an evolutionary step, and I'll explain why I won't call it an evolutionary step, but it's a different type of virtualization. Essentially, it's virtualization without the hypervisor part. So essentially what you have is, you have an operating system, and on top of that operating system, there's a bunch of capabilities that operating system has. Things like networks and disk drives and CPU and memory, process management, all that sort of thing. What container virtualization does is it says, I'm going to build a thin layer on top of the operating system that abstracts away these components. And we use direct calls to the kernel, in this case the Linux kernel. And I'm going to create a little virtual shell. And it's essentially a virtual machine that is run directly on top of the operating system. And there's a couple of reasons why this is sort of interesting. A couple of reasons why it's sort of interesting. One is it's very performant. So by taking the hypervisor out of the way and by taking a lot of the mechanics needed to abstract away different bits of hardware and things like that, you get a fair bit of grunt back on a machine. And the other aspect of it is it's very lightweight. So if you want to do things very quickly, very simply, very easy to create and delete things, you're essentially, you are writing at the kernel level very fast little operations, which means that instead of seconds or minutes to spin up a virtual machine, it takes sub-seconds to build a container. So as you can imagine, it's pretty attractive for a number of reasons, but it's not in the past, it's not been very easy to use. And probably the main container framework people are familiar with is a thing called LXC, which is Linux containers. LXC has been around and sort of supported in the Linux kernel since about the 2.6 kernel in various forms of support. It's well maintained and it's got a great team of guys who work on it. However, it's not very user-friendly. Like, you needed to be a reasonably solid sysadmin, understand a bunch of stuff about how the Linux kernel works in order to be sort of an LXC expert. So people have used containers in the past, but it's not been easy to do. And Docker's aims to change that model. So we have all these advantages containers offer, but the technology has been not easy to consume. So Docker kind of takes that and puts it together. And the key principle behind Docker is this standard shipping container sort of idea. Essentially what we've said to the world is that container stuff's pretty cool, but we need to build a shell or a concept around it that makes it easy to use. And the reason we've chosen shipping containers is, those of you familiar with the sort of concept of shipping containers, these things are only about 60 years old as a construct. Before that, when you wanted to put things on a ship, you looked at the ship and there was a quartermaster and a loadmaster and a petty officer and they all looked at the ship and said, we can take this weight of stuff and we can ship this sort of size stuff. Let's fit it together. And they fitted it together like a jigsaw puzzle. And you had to take important considerations like the weight had to be right, and you shouldn't put the gunpowder right next to the flint. All that sort of critical things like, possibly don't stick the thing that might leak in a storm right next to the really valuable carpets. All of that sort of stuff. It was a complicated exercise, and it cost a lot of money to do. So someone said, if we had these boxes, and we'll call them shipping containers, and these boxes, you could stick anything in them. They would be built the same way, they click together, they connect together, they've got the same labeling, the same codes, and you may not be familiar with this, but the concept of an ISBN on a book is actually a very shipping container-like concept. Every one of these containers has a code that tells you what company that owns them, and you can interrogate them. No matter where in the world, you can stick a barcode scanner against a shipping container and know exactly all its history and its details. As you probably see, watch something like 24, whether it shipped a nuclear weapon into the port of Miami or whatever. So Docker came up with the concept of, let's take this particular concept and apply it to Linux containers. And the way we look at this is that we want to be able to take your application and we want to be able to say, let's build some workflow around your application. We want to build your application once. And if you're a developer or a sysadmin, you want to say, this is how I build my this particular service or this particular application. I want to define that in such a way, and I'll look a bit later about how we define it. And then I want to be able to construct an image that represents this application. Then I want to be able to distribute that image to lots of different people, and I want them to be able to consume that image and run it in many places. And I don't want those people to care about where they're running it, and I don't want them to care too much about the detail. Like, all of that stuff's inside the container. Like, that's my application. I care about the stuff inside the container. All these other people just care about the outside of the container, where they can stack it, where they can put it, where they can ship it. So essentially what we're looking at is these little isolated boxes, and we added another little bit of technology on top, which takes advantage of a concept called union file systems, and this is like a layer. So essentially what we're doing is we build our container, and it's like loading different things into the container. So I say into the container, I'm going to load my operating system, Ubuntu, I'm going to load Apache, and I'm going to load some code. And each of those is a layer, and I can slot those layers in and out. And every time I have those layers, I can reuse them and change them. And it's a very simple model, and it provides a standard, and it means that we get that contact agnostic look at the world. So some of you, particularly those of you with longer beards and no hair like me, will go, this isn't new, the concept of this sort of workflow and this sort of containerization. Those who are familiar with Solaris Zones is a very much, we've adopted a bunch of concepts out of that world. And certainly if you're even older, my very first job was an IBM mainframe shop. Anyone who's worked with logical partitioning, it's a very similar concept too. So it's a very lightweight, really fast to run up, really easy to manage sort of model. So why should you care? First and foremost, it's a very easy and lightweight way to model reality. So if you think about the way that you build and develop applications, is that I'm a developer. I've got some code. I've checked it out of Git. I've worked on it a bit, and I'm probably on my laptop. And then I've said, okay, I'm gonna commit this. I'm gonna push it up to my GitHub repo or to my internal Git repo, whatever it happens to be. Please tell me you're using distributed version control. And then I'm gonna build it. Maybe build it. I've got some tests. So maybe I'm gonna build it on a test instance or a test VM. Run my tests. Maybe if that's successful, I'll promote it to the next environment, and so on and so forth. So this is a non-trivial exercise. And the reason it's a non-trivial exercise is you need to replicate a whole bunch of stuff. So you need to have an environment that looks something like production to test things in. If you've got a staging environment, that environment needs to look pretty close to production. You need to have test servers. You need to have a bunch of infrastructure. And more often than not, as a developer, you're not interested in that infrastructure. That infrastructure should just be there, right? You shouldn't have to go and ask somebody for that. Hands up here who's ever had to stop their development work because they had to ask for a sysadmin or an operations person or someone else for a resource of some kind. Hands up anyone who's taken that more than a week. Anyone taken more than 6 weeks? Okay. I used to work in a bank. Used to take 8 weeks to provision a server, like a test box. 8 weeks. Like a developer sends an email and says, I would like a server. 8 weeks later, they would get a box and they'd get an IP address and maybe some keys, and there was no guarantee that box actually resembled, for a lot of reasons, production. And then you had to then work on it and build it and change it. And you discovered that in the meantime, production had changed or moved on, or as a result, your environment didn't match reality. So Docker is an attempt to be able to say, I can build these very lightweight images, these very lightweight containers. I can build them myself as a developer. We provide you a very simple way of doing that. Or I can get these images from other people. They're extremely lightweight. They take seconds to download. And I'll give a demo at the end here about how this works. And then I no longer have to worry about that wait time. I no longer have to ask anybody for a resource. I can build multiple containers on my laptop. I can have something that resembles my production environment. And we have one of the major users one of the early adopters users of Docker is a company in New York called Gilt, who do fashion sort of stuff. They have a microservices environment, and the reason they find this so attractive is that they can replicate the entire microservices stack for a particular part of their product on a developer's laptop. No need for testing servers, no need for a production environment. They have all of those things, but an individual developer can work offline, essentially, with a pile of microservices that represent the production environment and test code against that. They don't have to ask an operations person for it. They don't have to ask a sysadmin for it. They get that replicated environment. And more importantly, devs care about their application. You care about the stuff that's inside the container, and ops care about the containers. And that's a really good demarcation. Some people have said to me, oh, is this an anti-DevOps thing? And I'm like, no, it's not. But the realistic thing about the world is that these guys are good at caring about the containers, and they're getting more a bit caring about this stuff in the middle here, but the primary focus of their entire lives is about this. If the developers are able to build something that the operations people know what it looks like inside and know it has a standard interface on the outside, makes this a very easy story to tell. Makes it very easy to use. And Mitchell this morning talked about golden images and about how images were previously a model that worked for a lot of IT shops, or rather didn't work. So this, because of its lightweight nature, is the same concept as those golden images, but because it takes minutes or seconds to reprovision those images, you don't end up with a huge drift of images across the environment. So I've talked a little bit about this, so I'll step through this quite quickly. Why not virtual machines or the cloud? The primary reasons are speed of deployment. It does take a few minutes to spin up a virtual machine. A container is a sub-second activity. Portability. Docker provides a standard API. You can run Docker in EC2, you can run it on a VMware cluster, you can run it on your laptop, you can run it on a Windows box. As a result, you get the same standard interface and the same standard API across those environments. It's very cheap from a size disk space point of view because of the sort of layering I talked about before. You can get a lot of density. You can put in, you have that hypervisor is removed, so you get a lot more bang for your buck out of every machine you deploy it on. Doesn't cost you anything. Well, we're going to sell you something at some point, but at the moment, it doesn't cost you anything. Those of you who are familiar with VMware's licensing model, it's pretty expensive to run a server farm of test boxes with VMware technology. It's a non-trivial invoice. If you can say to a CIO, we can cut in half or reduce the overhead of that cost, they can say to a CFO, CFOs like hearing things like 30% cost savings. So the technology stack really quickly. It runs on most Linux distributions natively. With the help of some bootstrapping, it runs on OS X and Windows. It relies on some kernel technology called C groups and namespacing. These have been in the kernel for a while. They are safe, secure, and relatively well tested. It's a Linux kernel. I mean, I can't promise everything. And we also rely on some, which I could describe as union file systems, things like device mapper, AUFS, VFS. But from the point of view of other than the benefits you get from it, it's not hugely critical you care much about this. We've also written our own container technology called libcontainer, which we released in the last release, which replaces the LXC, that Linux containers I talked about earlier, which means that now it's even one less dependency in there, and we're providing our own container technology. This is really loosely how what a Docker container looks like. There's a kernel, there's the kernel underneath, there's a file system, and you add each of these layers, steps of the process, there's a write-up container. I'm going to step really quickly through the basics of this and then include a bit of a demo because it's much easier to show than it is to tell and far more interesting. I will warn you, as working with children, animals, live demos tend to be dangerous. This worked this morning. There is absolutely no guarantee it's going to work now, and if it does, it's entirely the fault of the conference wireless. So this is how I build a Docker container. This is I start with what I call a Docker image. Excuse me. The Docker image is essentially a file, and we call this the Docker file, that describes what the image looks like. And it's a bunch of steps. The instructions are really simple. It says, I'm going to base it on another image, and this is a stock Ubuntu operating system. I'm going to run a few things. In this case, I'm going to install Apache. I'm going to set some environment variables. I'm going to do some configuration of the network. I'm going to say, expose port 80. And I'm going to run some commands. These commands are going to run when the container launches. So this is a very simple example, is an Apache web server in a container. It's 9 lines of code, which is considerably smaller than most people's Chef and Puppet cookbooks. It is purely, these instructions are basically bash-esque or bash itself, which means anyone can very easily learn how to do it. This Docker file can be shipped, it's text, you can ship it around, you can stick it in your repositories, you can attach the Docker file, stick it in the application's repositories, means you can see exactly how the image that runs the application is built. And you can keep it in version control, which means that if you change the way the image is built, you can always go backwards or forwards and things like that. So let's quickly look at building an image and see what happens. So, that's awesome. As I said, I'll blame the conference wireless. I did. So, thank you very much. Thank you very much. This is actually a DigitalOcean droplet that lives for the period of my demo and gets killed afterwards. So I'm not particularly fussed. If anyone compromises it, you're welcome to it. It hasn't got anything on it I care about. So here's the Docker file I talked about before. It's basically what you saw before. I've got one more line in here than the previous one. Sorry, I haven't updated my slide, obviously. I'm adding some code. In this case, I can add code one of two ways. This is a really important thing to know, particularly as the Docker containers, is I can add my code into the image itself. So what happens is when I rebuild my image, I can say, load all of my web applications code inside the image, which means that every time I make a change, all I do is rebuild the image. And because that's layered, it's very fast to rebuild that process. Or I can actually mount my code inside the container. So I can actually do like as if you're doing a mount on the command line, I can actually mount a particular directory containing the code, which means the container can be running. I can make a change to my application code, hit refresh on the browser. It'll hit the disk and says, oh, new version of the thing, load my HTML code. which means that it's an incredibly fast way to do testing. So, I'm going to build this container. For that, I just use a command called docker build. Oops. Sorry, I'm typing one-handed. I shouldn't type one-handed. I'll put down the remote. That just built that image. And I cheated a little bit here. Some of these layers may already exist. So once you've done that once, it keeps them cached. So as part of that process, when I built this morning, I forgot to delete the steps in the middle, so I apologize for that. But it took about 36 seconds, 35 seconds. That's actually now an image. More importantly about that image is that I can then push that image around. And we maintain a site we call the Docker Registry, or the Docker Index. And essentially it's a collection of about 10,000 different images that people have used. You can also run private registries, and as in behind your firewall registry. So I've got this image. I can then say, this is the new version of the Apache container image. I want to share this with the rest of the team, so that when they start building their containers, they can actually do they can use the updated version. I just go docker push. This one may or may not work depending on how aggressive their firewall is. So again, there was a few changes from this morning, but essentially the other thing about this is that, a bit slow. So, sorry? Are those layers? They are, in fact, layers, yes. So I've already pushed some of these layers before because I didn't change anything. I've only changed some later stuff. So it said, I can skip those layers, which means sending around this is very, very cheap. You only send the data to the registry that you care about, which is the change you've made. I can then tell the rest of the team, or I can use a webhook or something like that to notify the rest of the team there's a new version of the Apache image, and they can pull it down. And that's as simple as going, and this will, and it will only download any changes. So if this was the last layer I changed, with say a new version of the application code, I don't care about, Apache exists on there, everything else is configured, I don't care about those steps. I just get the 10 meg of my application that comes down again. So you can imagine how fast this makes your workflow. No more shipping around images, no more sending around vagrant boxes, you just get this, just the diff. And that's incredibly lightweight and fast. So let's see if I can just run a container from, I'm actually going to go back here and, so this is the very simple process of running a container. We'll see whether this, that has launched a container. So if I go docker ps, which is our equivalent of, I should see it's return, that process, this is the idea of the container. I can also give it a name. I could have called it Apache 2 or something. I can see here's my running container. It was created 5 seconds ago. It's been up for 5 seconds. It's based on this image. It's run this process. It's, that's launched Apache as part of that. And it's mapped port 80 inside to an external port of 49157. And so it does this port mapping here so you can run multiple versions of containers and things like that. So I could have, if I was a Rails developer, I could have multiple Rails versions running inside this, or pointing to different ports pointing out here. So I can see what my application looked like under multiple Rubies, multiple Rails. I can run bundler or RVM or whatever I like inside that. And that process, as you can see, that's considerably faster than starting a virtual machine, like sub-second faster. I can spawn a lot of these containers. I've run like, I don't know, a couple hundred containers on a MacBook Air doing reasonably process-intensive things. They're very lightweight, they're very cheap. I can dispose of them and restart them. In fact, if I go over to 149.157, I should be able to, hopefully I had time to actually update the DNS. That's actually so the index file is from a previous thing I did last week. but essentially that is the index.html I added inside the container. I can then go back and say I want to make a change. Actually, I think this one might be mounted. Did I mount this one or not? I just have to remember whether I yep. I got this wrong conference. What am I want to do here? I want to refresh something, refresh. What am I doing? Why won't you refresh? Sorry, I'm having wonderful problems of technical problems. I want you refresh. Okay, I can't remember whether this one's mounted inside the. It might be mounted inside the. Yep. Okay. Let me quickly. I will demonstrate a different way. I'm sorry, the demo was a bit ad hoc this morning when I discovered that that a couple of things didn't work. I can then go docker build. I'm essentially rebuilding the image I just created before. So you can see it ran through the process again. It only thing will have updated is the process by which it added the image. I can then spawn another container. I've now got another running container. I could have killed the old container, but instead it's just incremented to another port. And it'd be very embarrassing if this doesn't work. So that's the imagine that process is if I've just changed some application code. I've rebuilt my image. I've distributed that to all the rest of the team. They've got version 2 of the code, and I've got the right conference data in there. So, questions? Thanks very much, everyone. Feel free to ask me questions afterwards.